Okay, so today's notes are on continuously compounding interest. It's 7-2B. Our content objective is to write equations using E and solve continuously compounding interest problems. And our language objective is to use the correct terminology to explain continuous or describe continuously compounding interest. So in order to understand continuously compounding interest, we need to start by talking about our natural base, which is represented by the letter E. So E is pretty cool because it's kind of like pi in that it's an irrational number. So E is approximately equal to 2.718, but it continues on since it is, like I said, an irrational number. The decimal continues on forever. It's a never-ending, non-repeating decimal, meaning that its decimal does not have a specific pattern. It's just never-ending, continuing on indefinitely. So that's why it gets a special letter to represent it, because it is an important irrational number that's used in problems. Again, represented by E, and it's referred to as the natural base. So we're talking about it now because it's used for exponential functions, or used as the base for exponential functions that are continuously compounding. So I'm guessing some of you are like, well, what does compounding mean? And we'll talk about that in a second. But before we get there, one other thing I want to note is that E is equal to, so E is equal to 1 plus 1 over x to the power of x as x approaches infinity. So E is equal to, as we plug in infinitely large numbers, that's how we get such a crazy long decimal. As we continue to plug in infinitely larger numbers, E gets closer to the value of 2.718, continuing on. So I'm going to add this in here, the limit. So this is what it just means that it's approaching. You'll learn a lot more about limits in pre-calc, but this just means as x goes on to infinity, E is going to be that. Okay, so what is continuously compounding interest? Or what is continuously compounding interest? Well, what's cool about continuously compounding interest is it's basically a way, or compounding interest, if we take off the continuously part, compounding interest is when you add money into an account from the interest you've made, and then you get to make interest off of that interest. So when you are compounding interest, it means that you're adding interest into the amount that you can then continue making interest off of. So what I mean by that is, say you invested $1,000 and after a while you had made $1,050. Well, then if after you add that interest you made in, you can start earning the like 2% interest or the 5% interest or whatever percent interest you earned off of the 1,050. So you get to earn interest off of that interest that you've already made. So compounding interest means the interest is compounding, you're getting it into the account and then continuing to make interest off of that. So continuously compounding means that that interest is added on in infinitely smaller portions. So this is when you add infinitely small amounts of money to your account continuously. Sorry, not of your account. And earn interest off the extra money. Okay, so when you're continuously compounding, it means that every second that goes by, you're adding an infinitely, like a tiny piece of interest on, and over time, you're earning interest off of interest, and you don't have to wait till the end of the year or the end of the month or to have that interest added into the amount you're making interest off of. It's just continually added to the amount that you're making interest. So you earn money faster if it's continuously compounded. I'll attach a Khan Academy video that's pretty cool that explains how E is derived in there. So I'll attach that if you're curious and give you some extra credit points if you write that all down and can explain that to me. But for now, we're going to move on to what we're actually going to, or how to actually use E in the context of a problem. So we have a key formula here that we're going to be working with. And again, I'll attach the video that derives this formula because I don't like to just give you formulas and tell you that they work. So it's going to be just like the one we had before. So last section 7-1, we did compounding interest, where we had our principal amount, which we used lowercase a. This time we're going to use E. And then we had times 1 plus or minus the rate to the time. This is similar, and again, the video I'll attach will explain how to do this, but we're going to have AT equals P times E to the power of RT. So A equals PERT, where again, our A value is the amount in the account at time T. So that is our A value, the amount in the account at time T. P is our principal or our initial amount. Principal, initial amount. So that's our P value. E is our natural base. R is the same thing, it's our rate as a decimal. And T is still our time in years. And this is again rate per year, or interest rate per year. All right, so that's the formula we're going to use. I'm going to flip the page and rewrite it and then do an example. So I'm going to flip the page. So again, the formula we're using is AT equals PE to the RT. So AT equals PERT. And our example starts out, you won a contest at the beginning of freshman year. That deposited $3,000 in an account that pays 5% interest annually, or annual interest. Compounded continuously. How much will you have after you finish high school 4 years later? Assuming you take 4 years to finish high school. Okay, so the steps are pretty straightforward. So first thing, we're going to define our variables or assign amounts or determine. So define variables / determine values of the variables, because we already kind of know what they mean, but we need to assign them the values for the context of the problem. So again, I'm working with AT equals PE to RT. So I'm solving for A. So I'm leaving that alone. P is my principal or initial amount, which we know is 3,000. R is the rate, or E we know is just E. It's the number in and of itself. It's like pi, so I don't need to assign a value. It has its own value. R is 5%, which is going to be 0.05 as a decimal. So again, it's 5%, so it's 0.05. And then T is equal to 4. So I can make that an equal sign, sorry. So those are the values, and then I'm just going to substitute them into that equation that we have. So I substitute that in, and I get A of 4 equals 3,000 e to the 0.05 times 4. So 0.05 times 4, and then I'm just going to solve that out or compute that out. So I get A of 4 equals 3,000 times e to the 0.2. I plug this into my calculator, so then I get 3,664.20827, continuing on. Since I'm working with money, I'm going to write my answer with correct units and properly rounded. So again, since I'm working with money, I can't have a bunch of decimals. I'd have to cut it off at the end of cents. So I will have, or you will have, I should say, dollars, and you'll have 3,664.21. So that's how you do that problem. I'm going to write a quick check for you to do on your own. I'm not going to write a whole context, so I'm just going to say you invested $1,000 at 2.5% annually, compounded continuously, for 3 years. And I want you to figure out how much you have. So I'm not going to write the last part, but determine how much money you'd have at the end of those 3 years. I'm going to go over it now, so pause it if you need to. So you have A of 3 equals 1,000 is my initial amount, so P is 1,000. I'm using E since it's continuously compounded. And then I turn my percent to a decimal, so it becomes 0.025 times 3, my number of years. So then when I plug that all in, I get A of 3 equals 1,077.8841, and it continues on. When I round that and write it with my units, I get 1,077.88, and that is my answer. All right, write down any questions, comments, concerns you have on this so we can go over it together in class.